And we are live. Okay, Mocha, look at the camera. Yeah, she's trying to look. She's trying to look everywhere else, and I'm making her look at the camera by rotating the dog. So I'm rotating her eyes. That's a math thing, rotation. It's a geometry thing. Yes, it is still geometry. Welcome to Math with Doug. It is Geometry with Doug. We are doing volume now. And we will do this over 2 lessons. So that means we are only going to do 3 of the 3-dimensional shapes in today's lesson. The rectangular prism, the triangular prism, and the cube. And that's good. So we can do several examples of each, and I have some interesting ideas. I went around and I grabbed rectangular prisms and cubes from my household, which is something you can do. It's usually fairly easy to find cubes. Rectangular prisms are really easy to find. Triangular prisms, I don't know how many households have a lot of them. The only one I have in this household is this one that I made by folding a piece of paper. But I will draw a couple when we get to the triangular prism part of the lesson. So we're just finding volumes, which means we need to talk about volume. What is volume? Volume is the amount of space that a 3-dimensional shape takes up. I like to say volume is the same thing as capacity, but the reason I'm saying that is because questions that students are asked to answer often use the word capacity to test whether the student realizes, well, that means they want the volume. Capacity indicates that it's a container. So if the 3-dimensional shape is a container, how much stuff will it hold? How much water will it hold? How much sand or sugar or whatever you put in it will it hold? And that's useful because it's the way situational problems in geometry are very often involving containers. But of course, this is a 3-dimensional shape. This one happens to be a cube. Yes, we can see it's meant to be a dice numbered cube. But this, of course, won't contain anything because it's solid. It still has volume. That's what I'm talking about. I want to know what the volume is of this, even if I can't use it as a container. And then I might have something else like this, which clearly is meant to be used as a container. And I want to know its volume too. So knowing the volume of both of these things is useful. Rectangular prism, that's what I'm going to start with. Rectangular prisms are easy to find. You should find them all over your household. And I have a bunch of them right here. But I decided one of the angles I want to use for this lesson is to start off by showing you this shape, this 3D object, which is a charcuterie board that I made. My logo is upside down, there it is. So I'm showing off my logo and my charcuterie board. This is a nice piece of ambrosia maple. And it's not a perfect rectangular prism because if you look at it closely, you see that the edges are rounded, which is something I did on purpose. But it is still a rectangular prism. Even though it's quite flat, it is not paper thin. It has a thickness, it has a volume, and we can calculate the volume of this and any other rectangular prism that we want. Now, I have used this one here, which is also a rectangular prism. It's also a piece of wood. I've used this before for some of the past math lessons. Just to use as an example of a rectangular prism. It's been quite useful, and I'm going to show off one of the things you can do. Okay, so a piece of wood. This is actually a beautiful piece of wood, but it hasn't been sanded or finished, so you don't necessarily know what it's going to look like after you make something with it, after you make it look beautiful. And that's why I have this spray bottle of water, because one of the things that happens, okay, let's get a good look at it. You can see the grain, you can sort of see it. But when it's not been finished yet and you want to see what it's going to look like when it is finished, the trick is to spray it with water. So that's a lot of water, it's dripping all over the floor. But you can see how it makes the colors and the grain, the patterns pop. So that is a fun thing to do. I'll show off quickly a couple more of these charcuterie boards just because I want to put them out of the way. So there's that ambrosia maple one again. And this one, I forget the name of the type of wood this is. It's very stripy, kind of reddish, quite beautiful. more here. Again, I want to get it out of the way. This one I put handles on, but it's made out of teak. Everyone's heard of teak. Teak is a really cool wood. It has striking contrast in the colors. But all that just so that I can move them. I have another piece of wood, and I want to do some kind of a problem. Word problem, style problem, geometry style word problem with that piece of wood, and I'm going to spray it with water. But I'm not doing that yet. Okay, so what should I use first? I have a bunch of boxes. I went and I found boxes that I received things in. So some of the logos might look a little familiar. A lot of people receive things at their door, so I received this one at my door. But what matters to me right now is I want to calculate the volume of this. And it is a rectangular prism. So I'm going to use the volume formula for a rectangular prism, which is quite a simple formula. Where's my chalk? Volume of a rectangle prism is equal to length times width times height. So we can just write LWH. I'm showing the multiplication symbols. I need to know the length, the width, and the height, and then all I have to do is multiply all three of them together, and I will have calculated the volume of this box, which gives the capacity if it's empty and being used as a container, which was the purpose of it. But even if it was solid, I would still be able to find the volume. So let's find the length, the width, and the height of this thing. I'll use this ruler because there's clutter on top of my other one. And I will measure in inches. So the length, well wait, which is the length? Is that the length or is that the length? It's one of the issues when you deal with a rectangular prism is that it's quite flexible. You can decide for yourself which one you think is the length. So my temptation is to take that longest dimension and call that the length. And I see that that is nice 9 inches. Nice, clean 9 inches. Didn't even need a decimal. And then the width is going to be this one. So what's the width of this? 6 inches. It's almost as if the people who made this box and manufactured it chose these lengths and widths because they would be convenient for us to work with. Maybe they are convenient for somebody. And how about the height? 5 inches. Okay, so that is quite easy. It's easy for us to do the multiplications without needing a calculator. If we want 9 times 6, that is 54 times 5 will be 270. There, I did it. Of course, I could do it another way. I could say 5 times 6 is 30, and 30 times 9, that's 270. That feels easier. So no matter how I multiply them together, I have 270, and it is going to be cubic inches. Inches cubed. Because it is volume, and the unit of measure is cubed with volume. And we're not going to, in today's lesson, get into converting that to other units of volume like the liter. We can do that. We can learn that if we need to. I'm going to stick with inches for my measurements and cubic inches for my volume unit. But of course, cubic feet and cubic yards also exist. Cubic centimeters, cubic all sorts of things. Okay, but what if I had said, wait, no, I don't want to use this box like this with the biggest side down. I want to use it like this with the smallest side down. Well, then I'm going to say, okay, the length therefore is, I choose to say this length is 5 inches. That width is 6 inches, and the height is the 9 inches. Okay, so it's just going to be 5 times 6 times 9 when I fill in the formula. It's going to give me the same answer. Because, as you know, 3 times 4 is equal to 12, but 4 times 3 is also equal to 12. It doesn't matter which one you put first when you are multiplying. So 9 times 6 times 5 is equal to 5 times 6 times 9 is equal to 5 times 9 times 6. Any way you want to arrange the numbers. So that means I can, and that works well with the box. It works well with the rectangular prism. It means I can arrange this box with any of the faces I want on the bottom. And the formula will work. So I'm done with this box finally. I'm going to put it over here with those charcuterie boards. And we have done our first example. That's great. Took me over 9 minutes to get to it, but that's because I'm introducing the topic, and that's okay. Now I'm going to do a few more examples. I'm going to do them quickly. I may as well use this, a piece of wood that I sprayed with water before. I'm going to try spraying the other side with water and get more water all over the floor. And I'll do that, but that kind of makes it sprayish, so then I do this, and then I show it off. Oh yeah, it looks nice. After I sand it, put some finish on it, maybe some wax, it will look like that from then on. Fun. But what I want to do with this right now is find its volume. Which side is its bottom? What's the length? What's the width? What's the height? I'm going to make this biggest face. I'm going to make that be the bottom, and that means I feel like calling this the length. And therefore this is going to be the width. And this little bitty one here will be the height. Let's do that one. And I happen to already know the length and the width of that rectangular prism because I was using it in previous lessons to trace, to put squares on the chalkboard so we can find their area. So useful for making a square, but also useful as a rectangular prism. Where is my eraser chalk cloth? I'll keep the formula, and now we'll just fill it in with the values that go with this. So I already know that the length and the width of this are both 6.5 inches. So 6.5 times 6.5. I never used it as a 3D object before, so I hadn't measured the height. But the height is... it's almost 2 inches. It probably was meant to be 2 inches. It's about 1 7/8 inches. But we're not afraid of a fraction or a decimal. So that would be 1.875. 1 7/8 is equal to 1.875. Where's my calculator? I was using it before. Where'd it go? I want my calculator because Doug has learned his lesson. I'm going to double check. Yes, 7 divided by 8. Yes, it is 0.875. So therefore 1 7/8 inches is 1.875. But I need this anyway because I'm also going to give my answer for the volume. 6.5 times 6.5 times 1.875. 6.5 times 6.5 times 1.875 equals 79.21875. I'm going to round to the nearest tenth so that is 79.2 inches cubed. Say it with emphasis because I don't want the students to forget to apply the cubic unit when they're doing volume and to think about why the unit is cubed, because it's like this for a reason. Because the volume formula gets us to multiply 3 different measurements, 3 distances that have a distance unit, and all 3 of them were inches. So I didn't write inches, 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 but I multiplied inches times inches times inches. And what happens there, when you multiply 3 things that have inches as their unit, you end up with the cubic inch as the unit of your answer. So that means all of the formulas that we're learning, if they're going to give cubic inches as their answer, they all should involve multiplying 3 distances that are measured in inches. And that's what's going to happen. So we'll look at these formulas and think about that. And when we move on to the next lesson that I'm going to film after this one is over, we're going to continue to do that because I think it's part of the understanding the student develops of why this is like this. I know that it can be a temptation for students to say, volume is always cubic inches. Yeah, I know that. I always will get this right. But if they don't really think about why it's like that, then they don't necessarily really understand why it's like that. And understanding why things are the way they are is what helps us to really remember what we've learned in the past in math and be able to recall it when we need it. So I want to slow down and put some emphasis on that. Okay, I'm going to erase this little thing though. And in fact, I'll also erase my answer, but not right away. Because I want us to notice something. With this particular rectangular prism, the length and the width were the same. So, why would that matter? It doesn't really matter, right? That so long as we know the length and the width, and we're multiplying them, and then multiplying the height also, we're going to get the volume, it's going to work. So it works like in our first example when all 3 numbers were different, but it also works in this example where 2 of the numbers were the same. And because I had the length and the width the same, because I was choosing to hold my rectangular prism which isn't wet anymore. It's still a little damp. Because I was choosing to hold it with this face down, I was holding a square face down as my base. So therefore, it can be referred to as a square-based rectangular prism. Very useful to notice because they happen a lot. It's kind of in between the more common rectangular prisms, like the first one I did, that delivery box. It's kind of in between that and the cube. Oh, cube. The cube. Of course, the cube is the three-dimensional figure where all of the side lengths are the same, meaning that the length and the width and the height are all equal. It's worth thinking about. It's worth slowing down and thinking about. So a square-based rectangular prism will happen quite a lot, and it can change the way you have information given when you are solving a math problem that involves volume. If I tell you, I'm going to get that box again. If I want you to be able to calculate the volume of this box, I have to tell you the length and the width and the height. If you don't know all three, you won't be able to find the volume. So I have to give you three values. I have to give you three measurements, 6, 5, and 9. That's what they were. But if I tell you that I'm giving you a square-based rectangular prism, well, then I only have to give you two values. I have to give you that height, the 1 7/8 inches height. But I could say, well, the side length of the square base is 6.5. 6.5 and 1.875. We only have two values given, but we still had enough information to do this because we knew it was a square-based rectangular prism. Therefore, we were able to conclude that the 6.5 applies here and here. It makes sense. It seems obvious, but it makes sense. And it means that the way you get the information can be slightly different, and I need the students to be able to handle it when they get the information in a slightly different way, but they were given enough information so they could calculate the volume. I want them to be able to do that. I'm finished with this one now too, so I'm going to put it on the pile of all the others that I am finished with and grab something else. One more box. Oh, this one also seems to be square-based rectangular prism. It's a box that, I may as well show you, some of these handles, like the handles I had on one of those charcuterie boards, came in. I have several boxes like this with several different sizes and styles of handles and other things like that. And look, it really does look like a square. I'll measure it to make sure, but my suspicion is this is another square-based rectangular prism box. Why do so many of these boxes that we get stuff in turn out to have a square base? I don't know. It's got to be convenient for some reason, and we can think about that. But what we're going to do right now is keep practicing using this volume formula. I've already used almost 20 minutes. I want to get into some other stuff. Keep on using this volume formula. The dog's distracting me. She's rubbing her eyes by rubbing both of her front paws across her. She just can't help being cute. Okay, so I want to do this formula yet again, and I'm going to measure the side lengths and double check that it's really a square base, and maybe it isn't, and the height, so that we can use this formula again. But it was worth thinking about this slight different thing that happened because two of the side lengths, the length and the width, were equal. So this one, let's get the ruler. Let's measure. I'll just measure all three at once. Okay, this one. Oh, that is not 4. That is a little bit. 4 1/4. 4 1/4 inches. And then when I measure this other one, 4 1/4. So it is a square-based rectangular prism. The height is not going to be 4 1/4. The height is definitely smaller than that. So in inches, everything again. 2.5. 4 1/4 times 4 1/4 times 2.5 is what I will do in order to fill in this formula. How about I change the way the formula looks? Just because I know the students who are watching this lesson know their basic algebra, so they won't think it's weird to see me writing LWH, which is often how you see this formula. because we see the letters right next to each other and that means they're being multiplied. It's something that we get used to, and when students have learned a bit of algebra, they've seen this before, they see it a lot. But the length was 4 1/4, that's 4.25. The width was 4.25, so I'm doing not only the formula but also my simplification without using that times x shape times multiplication symbol. And the height was 2.5. And it happened again. Two of them are the same because it's a square based. Doesn't stop us. We still realize, okay, well, it means we're multiplying this number in here twice. Calculator. 4.25 times 4.25 times 2.5. 45.15625. I will round that to the nearest tenth, so it's going to be 45.2. Cubic inches, or inches cubed. Okay, this is starting to get routine, isn't it? I don't think students should only do 3 examples of something. Just because they find it easy by the second one doesn't mean 3 is enough. Not enough practice is not a good idea with math. You will end up forgetting something, especially in geometry, where there are so many shapes and so many different formulas. We have the area formulas. Then we have the surface area formulas. Then we realize, oh, there's lateral area and there's total area. So there's more than one type of surface area formula for most shapes. And then we get into the volume. There's a lot of stuff. So you will end up mixing things up or forgetting something if you don't practice things enough. So that's why it's good that we do this. But I want to move on. I'm going to do the word problem-y thing, which will involve rectangular prisms later. But I'm going to move on to my next shape, which is the cube. Yes, I showed it before. So this cube, I haven't measured it, or I may have measured it in a past lesson, but I forget. This time I'm going to have to grab the ruler and measure it. Now, one thing I'm going to do is I'm going to show the volume of a cube formula. I left enough room over here. That is volume equals s cubed. S being the side length. That same side length used in the area of a square formula. Area equals s squared. Okay, volume equals s cubed. But I want to do these, I want to show both formulas side by side. Well, I'll erase the answer for that little box, which is another thing I can get out of my way. I'm putting it over here with the others. And let's measure this cube. And what we'll do is we'll find its volume right here. How long is the side length in this cube? Oh, I would say that is 4.5. Well, all of them are going to be 4.5, right? It has, I'll double check, but if it's really a cube, then all 3 dimensions, no matter which way I try and measure, I'm getting 4.5 every time because all 3 are the same. So it's, like I say, the square-based rectangular prism is kind of in between the other rectangular prism and the cube. In between everything being the same and nothing being the same in terms of these 3 dimensions we are measuring. So it is 4.5, yes it was 4.5, it's 4.5 cubed. Which means I can find the answer in more than one way. I can do 4.5 times 4.5 times 4.5. I'll do it 4.5 times 4.5 times 4.5 equals 91.125, rounding to the nearest tenth, that will be 91.1 inches cubed. But I can also do, with this calculator, it actually has an x cubed button. Different calculators offer different things. All scientific calculators will allow us to do this, but some of them offer an x cubed button and others don't. So 4.5 x cubed equals, very fast, 91.125, same answer. Or I can do 4.5 y to the x key, and then I put 3, and then I hit equals, 91.125. So that at least 3 different ways of using the buttons on this calculator to simplify this volume formula. Just worth talking about because, you know, sometimes you use it, sometimes you don't. The fact that you can actually just multiply. If you don't feel like searching for a button, if it's a new calculator, and you know multiplication will work, it's good. It gives the student power to know that there's more than one way of doing it. 91.1 inch cube, but of course, what if I tried to do this cube with this rectangular prism formula. That sounds like it shouldn't be allowed. I wouldn't try to do a rectangular prism with the cube formula unless the rectangular prism happened to be a cube. Ha! Because this is a rectangular prism. It is a cube, but it's also a rectangular prism. Because what makes something a rectangular prism? It has to be a prism, which means that the face on the bottom has to be equal shape and equal size to the face on the top, and that's true with the cube. And the bottom has to be a rectangle. And, well, a square is a rectangle. We talked about this a little bit when we were doing the areas. So squares are kind of interesting and cool. Sometimes they're easy, but that tricks us into thinking that everything about them is simple and we should just look at them once and then move on because they're not interesting. Yes, they are interesting. The fact that that cube is also a rectangular prism is interesting, which means that I should be able to use this formula. A 4.5 inch length times a 4.5 inch width times a 4.5 inch height. We already know, because the first time I did this with the calculator, that's what I did. 4.5 times 4.5 times 4.5, and it gave me this answer. So 91.1 inches cubed. Either formula will work with the cube. Interesting to slow down and notice that. Does that mean that we should always be trying to use different formula than the one that we expect? Not necessarily. Know what formulas will do what. The cube formula will work with the cube only. A rectangular prism formula will work with the cube and the square-based rectangular prism and the non-square-based rectangular prism. So you could say it's more versatile. Okay, I need to do a second cube. I'm not only doing one example of a cube, and that allows me to maybe one last time use, and I'll do the same thing. I'll do both versions of the formula. One last time, I'm going to use, I think it's the last time, this little paper cube that I made, I think it was 2 weeks ago, which I've used in multiple lessons lately, that has somehow survived. This has not been sat on or eaten by a dog or any of the other things that could have happened to it. It's a rather fragile little thing. And do I even remember the side length? I should remember, because I chose the side length to make the largest one I could out of a single sheet of paper when I did the net drawing of the cube. Remember that? Well, if you watched the other video, you remember it. Okay, so what was the side length? It was 2.5 inches? Yes, it was. But I'll measure it just to make sure. 2.5 inches. Oh yes, that is exactly 2.5 inch side length. It's a cube, so I only have to measure once because I know it's a cube. So if you're not sure something's a cube, measure everything. If you're sure something is a cube, like, well, that big dice, I knew it was a cube beforehand. And I have some other dice of other sizes. Where is one? Find one. You can find one, Doug. Find two. It's hard to pick up because it's so small. Okay, so there's a dice. I know it's a cube. So I can measure one side length and then I'd have what I need and I'd be able to fill in this formula. Look how small this dice is. It's a really tiny little thing. Just right to accidentally be swallowed by a dog, so I'm going to be careful where I put it. But I don't want to use those, they're too small. The paper one's good. It was 2.5 inch side length. Let's do it. Let's do this formula. It's going to be nice and fast. 2.5 cubed, or 2.5 times 2.5 times 2.5. They're both going to give the same answer. I feel like using that y to the x button again. So if some students might not have really encountered that button before, you get to a certain point in math where you start using it a lot, but you can be at a certain point in math where you never used that button or needed it. So it just looks like this. And to use it for this one anyway, you type in the y, and then you hit that button, and then you type in the exponent. So the y is the base, which is the 2.5, and the x is the exponent, which is the 3. So that means I'm doing 2.5 y to the x 3 equals 15.625, which means 15.6 if I round it to the nearest tenth, inches cubed. I'll make this look more like the real button by drawing a rectangle around it. I can even try to show a 3D effect. Is that working? I can even make it give it some shading. Okay, I'm not going to do that. I'm not good enough at this. Okay, 2.5 cubed obviously is going to give me 15.6. 15.6 inches cubed. 2.5 cubed equals. Yes. Okay. 2 cubes is going to be enough, isn't it? Because it is easy. But I still encourage students to do more than 2. And I also challenge you to go around your household and see how many actual cubes you can find. So I found 3 different sizes of dice. I think I have a couple more sizes of dice around somewhere, but of course I am a math teacher. I tend to collect things like that. And what else do I have? I do have sugar cubes upstairs somewhere. Not all sugar comes in cubes. Some sugar comes pressed into things that are actually rectangular prisms. I've had those as well. But I have some sugar cubes upstairs. What other cubes do I have? The only one I can think of is that one I made out of paper. But it'd be interesting to just wander around looking and finding if you can find more cubes. Rectangular prisms, too easy to find. Every household will have probably hundreds of things that are in the shape of rectangular prisms. So that's a nice easy assignment. What do I want to do next? I've gone past the halfway point. I am going to do the triangular prism, of course. Oh, and I can do my checking off thing. There, checked off rectangular prism because it is several of them, and I'm going to check off cube because I did 2 of those. And since cubes are also rectangular prisms, that means I've done 5. But I want to do at least some triangular prisms, including that paper one I went to so much trouble to make. But before that, I want to show off the water spray trick and piece of wood again, because I want to do a word problem. And as usual, I don't want to write a really big paragraph, so I'm sort of doing a word problem without using the words too much. I will keep the formula, and it is the rectangular prism formula I will need. So I will erase the cube volume formula. My word problem situation is involving this piece of wood or boards that, like the one I cut this from. So where do I buy my wood to make these things is a place where they have exotic hardwoods. So it's not just construction pine, spruce, fir that is so commonly used for things like fences and decks and such. Then you have more variety and you get woods that can be very beautiful. Some people make flooring in their houses from the wood that they buy at this place. It's really what the place is for. It's very convenient for me because the people who are buying wood for flooring will want perfect boards that are not warped or cracked, and they buy a lot of it. And then the store occasionally gets a board that's not so perfect. It's a little chipped off on the edge. This one has a bit missing here. And they end up marking the price of those down, and then I buy them because not only can I still make things like charcuterie boards and other things from these imperfect boards, sometimes the imperfections are exactly what I like the most. If there's a nice knot hole where a knot was and has fallen out, I can fill that, and it actually becomes a feature. I turn a flaw into a feature. So my word problem is, okay, Doug gets a good deal on a whole lot of these boards. This is 1/5 of the board that I bought. But I want to buy, because there's a good deal available, I want to buy 200. So I'm going to start writing down some of the information. 200 boards. That's an A. Each 5 times the length of this one. This wood weighs, weight, mass. I'm not getting into the sciencey side of this and defining weight and mass. The wood weighs just a little thingy for sticking this into my pocket, which went flying off. I'll try not to step on it. Okay, I'll get that later. This wood weighs, and I'm going to use inches, and with wood, oh, I was walking right off camera there. With wood, it's inches. Even if you are somewhere where most things are measured with in metric systems, centimeters, etc. With wood, when I buy wood, it's in inches and feet. Not really yards, lots of inches and feet. Okay, so this wood weighs, I'm going to give the weight in terms of cubic inches, so it won't weigh very much. 1 cubic inch of this, which would be, you know, a little one, a little bigger than the dice, well, a little smaller than the big dice. 1 cubic inch would not weigh very much, so I'm going to say it weighs I didn't leave enough room. I'll write it here. 0.02 pounds per cubic inch. Aha! Well, that's interesting information that we need. I'll erase this extra 0.02. But the friend with the truck who will go to the store with me and move the wood knows the maximum mass or weight that the truck can hold. So he asked me, wait, how much is this wood going to cost? 200 boards. How much is it going to, how much is it not cost? How much is it going to weigh? Sorry, I saw something appear on the screen. I was checking it. Okay, so, all right, so, what is the total weight? If it exceeds the total, the maximum weight that his truck can carry, then it means that we have to do 2 trips, that sort of thing. So that's the point. Could make that a question mark. That is the point of this little geometry style word problem. So we need to know the total weight, which means we need to know the total volume, because we'll calculate, once we know the total volume, we will multiply it by 0.02 and it'll tell us the total weight of the load, and then we'll be able to answer the question. Okay, so that's kind of long to introduce the situation, but that's the thing about word problems. They get to be a little bit long to present, especially on a chalkboard. So what do? I have to measure this. Remember, the board is 5 times the length of this. I cut this into 5 equal pieces to make 5 small charcuterie boards. Maybe I'll glue 2 of them together side by side. They won't be that small. So I need to know the length, but in order to find the volume, because I need to know the cubic inches of each board and the total load, I'm going to need to know the length, the width, and the height of this. So again, it's a rectangular prism. It doesn't matter which face I want to say is the bottom. What is the length? What is width? What is the height? I just need all 3. So let's say I put it on like this. I have to measure this length. This ruler is not long enough. So I'm going to use this one. And if the length of this, 14 inches. Okay, I'll write that here. And then the width of the boards, imagine lots and lots of these would make some nice flooring, because this is cherry, actually called rustic cherry. Rustic. So for some reason, that store, they think this type of cherry is rustic cherry, and well, it's nice looking. I'll spray the water. It's an excuse to spray the water. I love the effect you get when you spray the water. 5 inches. So the length is 14 inches. The width, and which one we call length, which one we call width, which one we call height doesn't really matter. So I'll just write it like this, 14 inch by 5 inch, but I also need to know the height. And this is 1 inch. Aha! We have we have all the information we need to solve this problem. Don't have to measure anymore. I do know one thing I have to do, which is I have to hydrate me with this fizzy water, which is the blueberry pomegranate flavor. Oh yeah. But I also want to hydrate this piece of wood so that we can see. Okay, yeah, it looks kind of nice, but let's get it wet and see what it looks like once it's wet. And you see the color and the grain starting to pop. And yes, once that is on a floor and sanded and then finished and waxed, it's going to look nice. The idea of sanding and then finishing and waxing, what it does is it makes the wood look wet from then on. It allows you to see how nice it looks the way the water does, but the water evaporates and then the wood looks like this again. So that finish and the wax makes it permanent. All three of those charcuterie boards I showed off have been waxed. Yeah, they have mineral oil absorbed into the wood that makes them wet, and then the wax, which prevents the mineral oil from evaporating, so it keeps on looking wet for a very long time, and it makes all of those beautiful patterns pop. Okay, so that is the dimensions of this piece of wood, but I have to multiply the length by 5 because each board is 5 times the length of this little example. So I may as well get busy with that. What I can do, I could find the volume and then multiply the volume by 5, or I can just say I'm going to take this and I'm going to say 5 times 14 equals 70. So therefore, the dimensions of the actual boards that are going to be used as floorboards are going to be 70 inches by 5 inches by 1 inch. The width and the thickness, which I'm referring to as height here, have not changed, but the length changed. It got a lot bigger, therefore the volume is going to be bigger. The volume is going to be 70 times 5 times 1. Multiplying by 1 is kind of easy, isn't it? 5 times 70 is going to be 350, and 350 times 1 is 350, and our unit is going to be inches cubed. But I am not multiplying because I have to say times 200 boards. Because that batch that I can get at that deal at special price is 200 of these. You buy a lot of something and the price can go down. The price per board goes down because you bought in bulk. One of the tricks us consumers use, no? Times 200 boards. What I'm thinking is, how many charcuterie boards would I be able to make out of this truckload? Oof. But I didn't bring the price into this. It's expensive. When you want to make your flooring out of cherry, expect to pay a little bit more than if you use some of the other stuff like the pine. Or what a lot of floorboards are they might have a cherry veneer, which is a thin layer of cherry that has been glued onto some other less expensive wood. That is cherry all the way through. Okay, I don't even know what the price would be. Try to figure it out. Okay, times 200 boards. So 350 times 200, that's just a multiplication. It's going to be 70,000. Is that going to be it? 350 times 200 equals, yes, 70,000 inches cubed. And now I just have to multiply it by the weight per inch cubed, which is 0.02. So I'm multiplying times, I'll do it here, times 0.02. 1,400. That means, dollar sign, it's not dollars, it's going to be 1,400 pounds because this was pounds per cubic inch. So we're getting to see a geometry word problem which shows a kind of a practical situation, which happens a lot with geometry word problems. Word problems are always supposed to be real life situations, but this is a real life situation. There are people who buy this sort of wood for flooring all the time. Of course, 1,400 pounds of this wood, well, I have to ask my friend with the truck, okay, how's your truck feel about carrying 1,400 pounds? It's up to him whether we're doing it in 2 trips or not, but I didn't even bring in the price. Okay, yeah, let's just expand this little word problem just a bit. I'm keeping an eye on the time. I still want to do some triangular prisms. This board, which was 5 times this length, so it was 70 inches. cost $9. Now that's in my currency, so of course the price would differ, but of course the price from one store to the store down the street could differ. But $9 is actually a really good value, but I got that good value because of the defect. And this probably was not the only defect on this board before I cut it into 5 pieces. So probably costs a lot more than $9 if you get the perfect ones that people want for their flooring. But if that's 200 boards, 200 times $9, oh, that's $1,800. Now you can see how expensive it might get to put cherry flooring. And then maybe you'll think, you know what, maybe we should just get the flooring that's made out of the less expensive wood, but that has the cherry veneer. I have a feeling the flooring I'm looking at right now, it just has a veneer. Very thin strip of wood, not quite paper thin, but not much thicker than that. Lie down. Stay. That has been glued onto that less expensive piece of wood. Okay, so instead of $1,800 for that truckload, it could get a lot cheaper. Okay, I am starting to ramble on about this situation. We have our answer. I'm going to erase and do some triangular prisms. The triangular prism is a prism. So there are things it has in common with the rectangular prism. So we will talk about that. I will keep the V equals because we are going to need to know the area formula for the triangular prism. But with these prisms, once you get into the less common shapes, you start getting formulas that are given in this form. Area of the base times the height. Okay, so that might seem weird, but it means that once we realize what we mean by this, the students will realize, oh, I already know how to do this. Because it isn't going to be hard. Here's my triangular prism that I made by folding a piece of paper together and taping it. I have to measure the length. Well, actually, I don't have to measure the length. It was a regular sheet of paper, so the length of this is 8.5 inches. I know that. I'm going to have to do some measuring to find the other dimensions we need. What is the base? Well, if I hold it like this, it looks like this is the base, right? This flat thing, which is a rectangle. But no, we can't call that the base, because if we do that, then it's not a prism. The prism is the shape where the base is the same size and shape as the opposite face. That didn't happen if I hold this part down. So even though it's convenient to hold this rectangle face down with this triangular prism, I still have to see that the triangle at the end and the triangle at the other end is the base and the opposite face to the base. So that's one of the challenges with the triangular prism and some other prisms, is that they're not always presented to you with the base down. You have to do this. That's easy to do when you're holding it in your hand. When it's a drawing on a piece of paper, you have to sort of do this in your head. And that is part of the visual and spatial orientation, which is a part of geometry. It's kind of cool, it's fun, but it's work. It's a step that has to be done. You can't skip over it. So you have to practice that, and that means we will do a few triangular prisms, and then we'll be done, because I only have 11 minutes left. Okay, so what's the area of the base of this? If the base is the triangle, well, it's the area of a triangle. That's why this isn't hard. It looks weird, but it's not, because it's going to be this time the area of the triangle. I'm going to do that here. Area of a triangle formula is equal to base times height over 2. And we were using that weeks ago. We've done a lot of work with the area of a triangle formula, so we're thinking, oh good, but wait, there's a height in the triangle. But there's another height here. That is another little tripping point. The two-dimensional shape, the triangle, has a height which I am sort of tracing with my finger here. It has to be perpendicular to the base, remembering some area lessons that we have learned. But then we're also calling this the height. The length of the tube is the height in this formula, and the height of the triangle is the height in this one. The fact that this formula has two h's that mean two different things is one of the things that makes us need to slow down and practice it quite a bit, so we get the hang of it and we can't be confused by that anymore. Now I'm going to get the base and the height. I'm not going to try to use formulas to calculate the height. This lesson isn't about that. I'm going to just measure them. So the base, and this won't surprise me, I just don't remember. 3.5 inches. So the base of the triangle is 3.5. And the height of the triangle is about 3, so that's measured. So I don't know if it's perfect, but I don't care. I'm just going to use the measured value. And so I have 3.5 times 3 divided by 2. That's going to be 10.5 divided by 2. It's going to be 5.25. And I can get that without having to round, and I'm glad because I'm not finished. That's the area of the triangle, which is the area of the base. I then move into this formula and I put the 5.25. Not 5.52. 5.25 times the height. Remember, the height was 8.5 inches. Now remember, the area of the base is what's here. This is an area. If I showed its unit of measure, it would be inches squared. It's an area. But then I'm multiplying it by the 8.5 inches, which is the length of the tube. I'm going to finally put this thing down on the ruler. But I am going to get my calculator and double check my math. 3 times 3.5 equals, yes, that's 10.5, divided by 2 equals, yes, it's 5.25. I didn't make a mistake there. Now I still have to multiply by the length of the tube, that height. So 5.25, which is already sitting in here, times 8.5 equals 44.625. I will continue my trend of rounding to the nearest tenth. So 44.6 inches cubed. And finally I get back to something that I was talking about before. With the cube, we mentioned we multiplied 3 things that were all measured in inches, which were the side length. All 3 of them were the same. So the side length times the side length times the side length, inch times inch times inch, you get inches cubed. The rectangular prism was the length, the width, and the height. They were each measured in inches, so you did inches times inches times inches, 3 times inches cubed. And now, how did I do that here? It's not as easy to see. Base, inches, times height, inches, times that other height, the length of the tube height, inches. There are 3 of them. It keeps happening. Because that's what makes this make sense. The unit being cubed makes sense. That is good to slow down and think about. Okay, but I don't want to slow down too much because I have 8.5 minutes left only. I can't believe how long it took me to do that truck full of wood word problem. No matter how wonderful it was, it took too long. So I want to do 8.5 minutes. I would like to do at least 2 more triangular prisms. I don't have any more to show you. But I will point out that you're not going to find triangular prisms in a typical household very often. If you find any, tell me about them because that's interesting. But the only one I can think of that most people would have at least seen in their lives is the box the Toblerone chocolate bar comes in. Not the chocolate bar itself, because it's too much of the bumpy thing happening. It's not really perfect triangular prism, but the box that it comes in is a triangular prism. It's kind of like this, except yellow. And smaller? Oh, there's large Toblerone. The ratio of the area of the triangle and the height is different. Okay, just different sizes of Toblerone. I should buy a bunch of those so that I can eat the chocolate. No, I should buy a bunch of those just so that I can keep all the boxes and use them the next time I'm doing the surface area and the volume formulas for the triangular prism. But what I'm going to do now is I'm going to erase this answer and do another one, and the one I'm going to do, I'm just going to draw it. So, keeping the formula, I need space for a drawing. I'll erase all this stuff which I should have erased before anyway. I'll take a sip of my fizzy water. Just like wood, to look good, I need to be hydrated. Okay, drawing a triangle, I should draw it with a ruler so that it's not just a sloppy triangle. So I'm going to draw, can I do this with a right triangle? I think I can. So I'm drawing it, I'm not trying to measure how long I want it yet. Can I do this with the right triangle? Let's see, I'm challenging myself. so I'm drawing a right, I'm drawing a right triangle. Okay. Oh, drop that. While I'm picking this up, I'm going to also pick. Ah! Oh, this is just becoming a comedy show. Then I'm going to pick this up. This thing that goes on here somehow. I'll do it later. Okay, so I need to know how big this triangle is because I want to draw another one the same size because a prism has to have a base that is the same size and shape as the opposite face. So if I want this drawing to be any good, this is 6.5 inches, this is 4.5 inches, and this is just a little less than 8 inches. So let's see, how can I do this so that it'll turn out nice? I'm going to offset it a bit. That is my instinct. 6.5 inches. Yes. 4.5 inches. And then this should end up being 8 inches if I did my right angle well. And just less than 8 inches, I guess. And it looks pretty good. Okay, so how do I turn that into a triangular prism? I'm going to connect, I'm going to draw the tube. I have to decide where's the outside, where's the inside. I think I'll draw a line here. And now I have to connect these two, but I want to use a dotted line because that's the bit that you wouldn't be able to see if it was an opaque solid object. Oh, that's not too bad. I'm not too ashamed of that. It's a right triangle. And that means this is also a right triangle, but I won't try and label that. Messy, actually. I thought it was a good drawing at first, and now I'm not so impressed with it, but I'm running out of time. So, okay, so I need my measures. That was 6.5. This base here, there, I'm not drawing this well at all. This base here is 4.5 inches, and then the length of the tube thing that I did, the height of the prism, is 11 inches. Which means I have enough information to do this. The area of the triangle is going to be 6.5. No, well, I want to be fussy. The base looks like 4.5 times the 6.5 divided by 2. Calculator. 4.5 times 6.5 equals 29.25. Still has to be divided by 2. Which is going to be 14.625, is it? Divided by 2, 14.625. Since I didn't have to round, this is as far as that decimal went, I want to keep it all and not round in an intermediate step. So the area of the base is 14.625 inches squared. 14.625 times the height, which is the 11. Times 11 equals 160.875. 160.9. Final answer, I will round to the nearest tenth again. Inches cubed, squared. No y. Think about y. This is an area, so it's squared inches, but then I multiply a third dimension in, which turns that 2 into a 3. Thinking of it that way is another direction to think of it, about it in. 1.5 minutes. I have time to do one more. I don't have time to draw it. So what I'm going to do is I'm going to just talk about a triangular prism, and the base and the height are going to be, I'll just write them, base and the height of the triangle. How about a 10-inch base and a height of 9 inches, and then the length of the tube, the height of the prism. So, where am I going to write this? I don't even know where to write it. I'll write it here. There, pointing at that H. It's going to be, that's like this one nice and long. How about 100 inches? Okay, I have enough information. I can erase this drawing because we finished it. And I have just enough time to get one last triangular prism volume. And then we'll say goodbye, and the dog will say goodbye, and then she'll get her supper, which is why she's getting all fidgety. Okay, so we have 10 times 9 over 2, that's 90, over 2, which is 45. It will be square inches. I'm sticking with the inches measurements for this lesson. And then the area of the base, therefore, is the 45 times the height, which is 100, equals 4,500 cubic inches. There. 100-inch long. More than 8 feet long. That's a long, that would be a big Toblerone. Imagine oh, I'm getting hungry like the dog. Okay, I'm starting to think of my own supper. Okay, it's time to end the class anyway. Thank you for being here. It was wonderful as usual. The dog will wave goodbye. You're heavy enough that I think maybe you don't need any supper. Should we skip that for today? Okay, thank you for being here, and I will see you next time.